Okay, so I'm going to split this review video up into 4 parts. First part is discriminants, second part is solving quadratics, third part is solving systems, fourth part is going to be your regression. So this is part 1. Okay, we're talking about finding the number of solutions by finding the discriminant. So the first thing you need to do in order to find the discriminant is you set everything equal to 0. So I'm going to add 7 here, add 7 here, and so I end up with 3a squared minus 6a plus 9 is equal to 0. Now your discriminant is b squared minus 4ac. It's the square root part. You never put the square root in. Okay, in this case, a is 3, b is negative 6, and c is equal to 9. So, it's b squared, so this is going to be negative 6 squared. You have to put this in parentheses. That's really important, because otherwise you're going to get the wrong answer. Minus 4 times 3 times 9. When you put all of that in your calculator, you end up with negative 72. When your discriminant is less, so when your discriminant is less than 0, you end up with no real solutions. Okay, that's what you learned in Algebra 1. Or you could also, or what we're looking for is 2 imaginary solutions. So we move on to the next one. You have a couple of things that you could do. You could add 3n squared or subtract. I'm going to add 3n squared, but if you do it the other way, you'll end up with the same solution, so don't worry about that. 0 is equal to 3n squared plus 6n plus 3. In this case, a is equal to 3, b is equal to 6, c is equal to 3. Okay. I put it in for b squared minus 4ac, and so that's going to be 6 squared minus 4 times 3 times 3, and your discriminant ends up being 0. Okay, that means that if it's 0, so if your discriminant is equal to 0, you have one real solution. Okay, and rational. Okay. This next one, we set it equal to 0. You can go either way. For this one, I'm just going to subtract 2p squared, subtract 2p squared, make sure that my p's are together. So this is negative 1p squared plus 5 is equal to 4p. I'm going to subtract 4p. I'm going to subtract 4p. I can't combine it with anything, so I just rewrite it. Negative 1p squared minus 4p plus 5 is equal to 0. Okay, in this case, a is equal to negative 1, b is equal to negative 4, and c is equal to 5. So we do b squared, so this is going to be negative 4 squared minus 4 times negative 1 times c. You see again, I have that parentheses around that square root, and I end up with positive 36. Whenever your discriminant is greater than 0, you're going to have 2 real solutions. I have the sidebar just in case you also know that those are going to be rational, because 36 is a perfect square. So let's move on to these problems. On the coordinate plane below, draw a function whose discriminant is 24. So if the discriminant is 24, that means that you have 2 real solutions, which means that 2 real solutions means you have 2 x-intercepts. Okay, so you just draw a graph. It could be concave up, it could be concave down. You just need to make sure that it intersects the axis in 2 points. Okay, so there's a lot of different answers that are correct with this. For B, we have 0. We know that that is one real solution. So this tells you it's going to have one x-intercept. Okay, one x-intercept could look something like that, just as long as it only intersects the graph in one spot. Negative 53, well, if your discriminant is negative 53, those are going to be 2 imaginary solutions, and this is going to be no x-intercepts, or 0, x intercepts. Okay, so your graph could be pretty much anywhere because we don't really know much more about the problem except for the discriminant. There are a lot of different things. So that is that. 3 is give an example of a discriminant with the roots below. All you have to know is, well, for it to have one real root, well, your discriminant would have to be 0. 2 real roots, okay, so that's where your discriminant is 0. 2 real roots is when your discriminant is greater than 0. So you can just pick a number, whatever your favorite number is that's greater than 0. Let's do 345. That works. And C, 2 roots with imaginary components, that's when your discriminant is less than 0, so pick your favorite negative number, maybe negative 153. Okay, and that's the video for discriminants.